In this video, you will learn how to merge exponents and roots. As you can see, I have this equation here, a to the 1 over n equals the nth root of a. So it's important that you know that you can change if you have a number or a variable and it has an exponent that looks similar to this, you could change it to a radical. As long as that number here, see this number right here is the same number that's right here. And this 1 in the numerator here is considered to be the 1 that's out here, but of course we don't write exponents of 1. It's understood, so that's why you don't see that 1 there. So you don't see that, but you do notice that that denominator, that number in the denominator is the same number that's here in the index. Alright, so that's basically what you need to know in this section, that these two things are equivalent to each other. You can change an exponent to a radical, or vice versa. You can change from a radical to an exponent, as long as you know this equivalent definition. Alright, let's go to this first example here. It says 4 to the 1/2. Now if we wanted to change this to a radical, already we know that that number in the denominator would be the number here. See, so that's the denominator, that's the denominator, it goes here. So I'm going to change this to a radical, and that way it'll be the square root of 4. Now let me say this about square roots: we don't normally write 2 for square root symbols. We don't. So normally you're supposed to have a little 2 here, right? But it's just understood for square roots, for whatever reason, that 2 is understood, and that's the square root symbol. Alright, and it turns out we can simplify the square root of 4, so the final answer is just 2. So 4 to the 1/2, if you do the algebra, you'll see that it is equivalent to 2. Alright, let's go to 64 to the 1/3. Now what is in this case, or what goes in the little v part of the radical, the index? Alright, so this is the cube root of 64. And then can we find the cube root of 64? I believe 4 times 4 times 4 is 64. So you must keep going. So the final answer is 4. So 64 to the 1/3 is 4. Let's go on to x to the 1/4. So even if we have a variable, if you were asked to change this to a radical, you can, because this is the same thing as the 4th root of x. Now in this case we can't simplify the 4th root of x, but we can change it to another form, a radical. Alright, here I wanted you to see that this 1/2 is actually an exponent that goes with the 9, not necessarily the negative. So this is the same thing as -1 times 9 to the 1/2. Wouldn't you agree that these are equivalent to each other? Now notice that it's 9 to the 1/2, not -1 to the 1/2. And some people make the mistake of putting a negative under the radical, but it actually goes outside of the radical. So you have negative the square root of 9, which is equivalent to -3. Alright, let's keep going. Alright, here we have a to 1x to a to the 1/4. If we want to just go ahead and put this under the radical, if we want to go ahead and put this as a radical, it will be the 4th root of 81x to the a. And here's what I want you to see here. You can actually simplify this a little further. you want to see, can you break down any of this? We can definitely break down x to the 8th, and we also need to see if we can break down 81. So is there a number times itself times itself times itself that will give you 81? So that's what you need to check now. So you take out your calculator and figure out, is there a fourth root of 81? It is. It's actually 3. But also x to the 8th. So let me write this another way. We know that it's 3, right? But we also know that x to the 4 times x to the 4. If we add 4 plus 4, we get the 8. So we can break it up like that because of this 4. So we know that we can take a 3 out because 4th root of 81 is 3. But also the 4th root of x to the 4th is x. The 4th root of x to the 4th is x. So x squared comes out. So 3x squared is your answer. In this problem, 5y to the 1/3 is similar to that negative problem that was in the front. That 1/3 is actually, that 1/3 goes with the y, not the 5. And a lot of people make the mistake of thinking that the 5 and y, they're stuck together, but they're not. This is equivalent to 5 times y to the 1/3, and as you can see, that 1/3 only applies to the y, not the 5. This is multiplication, but you can separate the two as long as you know you have to multiply. So you can write this as 5 times the cube root of y. Can't simplify there, so you keep going. Let's go to some problems where the numerator is not 1. So in these cases, you'll see that you have, for example, a 3 in the numerator. And so we're going to call that m. And that m either goes here or, like I mentioned earlier, it goes on the outside. I prefer this format here. So I prefer this one. So that's what we're going to use. But all of these, as you can see, are equivalent to each other. But I prefer rewriting exponents in this way. Alright. So again, we look to our denominator to find out what root it is. And as you can see here, we have the 4th root. This number still goes under the radical, but now we can put all of that to the 3rd power because that number goes here and that number goes here. Okay? So what is the 4th root of 16? It's actually 2, but we still have that cube, right? 2 cubed equals 8. So that's how you will simplify this type of problem. You have negative 64 to the 2/3. Notice that even the negative now is inside of this parenthesis, and this 2/3 even applies to the negative. So now this negative will also go under the radical. You have cube root here of negative 64, but all of it's being squared because of this 2 here. The cube root of negative 64 we found out was negative 4, but it's being squared, so the final answer is 16. Alright, we have 4 to the 5/2. That's the square root, right? Square root of 4, but all of that is to the 5th power. The square root of 4 is 2, but all of that is to the 5th power. So 2 to the 5th power equals, in your calculator, 32. Also, negative 8 to the 4/3. You find the cube root of negative 8, all to the 4th power. Cube root of negative 8 is negative 2 to the 4th power. and that should be a positive 16. And the reason why you do the cube root of negative, because negative 2 times negative 2 times negative 2 is negative 8. So you can find the cube root of negative numbers, but you can't find the square root of negative numbers. You'll go off into complex numbers, and you'll see that in pre-calculus a lot.